All right, finishing part 2 of section 4.5. So I'm trying to go more slowly, explain carefully. One of the strategies you want to use for this video is to pause and think about what I've said. If you're confused, don't keep listening to me go on and on with the next problem. Pause it, maybe draw the triangles, look at the information that was given, and then go back and listen to what I said again to see if you understand it the second time around. If you didn't understand it, come see me, go up to my desk. I know there might be people quizzing, but maybe we can have a quick chat. You can say, I didn't understand this, I can try to explain it to you in person, and then you can move on from there. Okay? If you didn't have a chance to watch it in class, you're watching it at home, then try to pause, watch it again. If you can't, or you still don't understand it, then come see me, ask me during class. And we can review it, and if you weren't able to do your homework, well, you'll just have to make up for that another night. Okay, so see how it goes. So for each of these diagrams, again, they're a little more complicated. We have overlapping triangles in every single one, and I don't identify which triangles are going to be congruent to each other. So you might have more than one pair. That doesn't mean that those pairs, there's going to be more than one pair congruent, but you might have more than one pair of triangles. So here we have this triangle AEB, and this triangle CDE. Those look like they could be congruent. And then we have these bigger triangles, CBA, and this bigger triangle, BCD. So those also might be congruent to each other. So you look at the given information, and I would say color coordinate when you're going through this. If you have colored pencils, then get them out. So we have AB is congruent to DC. Okay, so those sides are still part of both triangles, both this little triangle here, these little triangles, and both part of the big one. So that didn't help me a lot. But now look at the next one. AC, okay, so that's pretty much telling us we're only looking at the larger triangle. AC is congruent to DB. So now I can almost separate that. I can't almost, I can, sorry. So I have BCA, that's my red triangle. So I would go down like that, and I would have vertices B, vertex C, and vertex A. I know that this is one mark, and I know this is two marks right here. So that's a double mark. And then if I redraw my blue triangle, sorry, I'm getting those too close together. Let me erase and redo. So if I redraw my blue triangle, I would have a B here, a C here, and a D here. My DC was congruent to AB, and my BD was congruent to AC. So now I need a third part. In order to prove triangles are congruent, I need three pieces, unless it's a right triangle. And there's no right angle or perpendicular here to indicate that, so I can't do the right triangle, I can't do the HL. So do I have shared angles in either of these? No. Even though this is a B and this is a B, they're different sized angles. You can clearly see that. We have shared C's, but those are different sized angles. So hopefully you guys are screaming at me saying, it's obvious it's BC, BC. They're shared. This part right here is shared in both the red, right, and the blue triangles. So that's the reflexive property. BC is congruent to BC, right? If we were going to make this a proof, BC is congruent to BC. Why? Because it's the reflexive property. Therefore, these two triangles are congruent to each other because of S, S, S. All right, let's move on to the second one. Again, I have multiple sets of triangles here. I have these LQM and PQN. I have this big one LNM, PNM. So I'm trying to look for a pair of overlapping triangles that are congruent. So let's look at the given information. So I have angle 2 is congruent to angle 3. And I have angle 1 is congruent to angle 4. Okay, well, what triangles do I have there? I don't see any specific triangles that that's necessarily zeroing in on. So I want to look maybe at other possibilities. If these two angles right here are congruent to each other, then that means this is an isosceles triangle. and their sides opposite are going to be congruent to each other. So MO is congruent to NO. Why? Because of the ITT sides, right, or 4.2. So now I have an angle and a side right there. Oh, and then I see that these angles right here are vertical angles. So LOM is congruent to angle PON because of vertical angles, right? So these are vertical angles, the vertical angle theorem. So it's a VAT right there for the purple. And then I have blue, I have this red segment, and I have purple, I have blue, double angle, single side. Can't see this one very well. This side and this side are congruent right here. And then I have my purple angles because of vertical angle theorem. So that gives me two triangles are congruent. It's this triangle, LMO, and that's going to be congruent to this triangle over here, PNO. Oops. So there we have it. LMO is congruent to PNO. Can you prove other triangles are congruent in this diagram? Probably. Probably you can. What would it be? Well, the only other choice would be these big triangles. So can I prove this big triangle, LMN? So if I separated this, LMN. Okay, so I've written, sorry I had a little pause there, so I don't know what I was saying. I've written triangle LMN separately. Now I'm going to draw triangle, sorry I'm running out of space here, MNP, vertex M, vertex N, vertex P. Now let's see if these two triangles are congruent based on the information we've been given. So we've been given that angle 2 is congruent to angle 3. Well, 2 is in this corner here of this purple triangle, right? It's this tiny angle here, and 3 was in this corner here of the orange triangle, down over here in this orange triangle. So I know these are congruent to each other. And then it says 1 is congruent to 4. Well, 1 and 2 make up this angle here, and 3 and 4 make up this angle here. So if 1 is congruent to 2 and 3 is congruent to 4, then by the addition property, 1 plus 2 is going to equal 3 plus 4. So these must be congruent to each other. So I'm going to put the double marks here. And then what else do you see? Well, you should see that MN is shared in both of these triangles, right? It's in the orange one and it's in the purple one. So MN is shared in both. So once again, I have an ASA situation. Sorry, so I didn't write that here for this blue one. This blue one was ASA, right? These triangles here because of angle, side, angle, angle, side, angle. And then these are also going to be true because of ASA. So triangle LMN is congruent to triangle PNM, PNM, LMN because of ASA. Again, this is quite muddled through here. There's not enough space. So if you have questions about what I did, please come see me and ask me during class right now, or ask me about it in class to open class the next day, and I'll explain it. Okay, moving on. Number 3. Number 3, to me there's just two big triangles we're going to check. It's either this blue one or this red one. There's only one more triangle in here, and that is not equivalent or congruent to anything else. So I'm going to look blue and red. Are these congruent and why? So let's mark what's given. Well, I know that WU is congruent to SZV. And I know that WX is congruent to YZ. Oh, those are just little pieces there. And then I can see that XY is shared in both of them. So if XY is shared in both of them, again, WX plus XY must equal, oops, sorry, wrong notation there, must equal YZ plus XY. Why? Well, this is the reflexive property, xy equals xy. And then because of the addition property, we should be able to add it to these two things because those are equal to each other as well. So therefore, we have this blue, we have the leg. Oh, and look at this. Here's a right angle. And what is opposite the right angle? Is this entire leg here, which is known as the hypotenuse, not a leg, sorry. So opposite the right angle is the hypotenuse. So we have a leg and a hypotenuse, or a hypotenuse and a leg. So we have triangle L, or sorry, that's not an L. What letter is that? U. Triangle UWY is congruent to triangle, well, we have to go U to W to Y, so it's going to be V to Z to X. V, Z, X. Why? Because of HL. Okay, let's do this final problem. I think we're going to have more than one pair of triangles because there's a lot in here. We have these little ones here, we have these big ones here, we have these little big ones here. My guess is that these tiny ones, E, B, whatever here and here, aren't going to be congruent, or we're not going to bother with them because there's no intersection point labeled here. So this doesn't have a title. If it does, we could probably title those as being congruent as well, but maybe not. Okay, so let's mark some information. We have these being perpendicular, right? So AE is perpendicular to EC, AD is perpendicular to DB, so I know I have right angles because of the definition of perpendicular lines. So let's look at that. To me, I instantly see right triangles. So here's one. So here's a right triangle. So that's A, E, C. Vertex A, vertex E, vertex C. Here's my right angle. To me, it looks like it's going to be congruent to this triangle, if any triangle. So I'm going to go ahead and write that one out separately. So I have A, I have D, I have B. Here's my right angle. Okay, so now let's go back and see what's given. Angle ABC, okay, let's see here. ABC is congruent to angle ACB. So these big angles down here in the corners are congruent to each other. Well, that doesn't relate to these specifically, but it does tell us that their sides opposite, and the side opposite is this AB side right here, and this AC side right here. Why do those have to be congruent? Well, that's because of ITT sides. If their base angles are congruent, this must be an isosceles triangle, therefore the opposite sides must be congruent to each other. So that's ITT sides. Now look up here for this red triangle, right, for this red triangle here, and for the blue triangle here. What do you notice? Well, up here is angle A. So vertex A, vertex A. In this case, both of those angles were the same, right? So they are the same exact measure. So I have angle, angle, side. So these two triangles are congruent to each other because of angle, angle, side. Now, you need to write them out. Triangle ADB is congruent, so we went from A to D to B, so I have to go from A to E to C. It's congruent to triangle AEC. So that's one pair. Let's look for another pair. Okay, I erased everything in order to look for another pair, otherwise it would have gotten confusing. So I'm going to look at this triangle, EBC, right, EBC, and then I'm going to look at triangle BDC. So BDC. Let's mark what we already know. We know that these are right angles up here. Okay. We also know that in the red triangle, that's this angle B, is congruent to the blue triangles C because of this statement right here. Right? So that's where I'm getting these two equivalent. And then my third piece is BC is shared in both of them, the exact same segment. So therefore, once again, because of AS, angle, angle, side, we know that these two triangles are congruent. So that would be triangle, I don't know where to write this, triangle ECB is congruent to triangle, so I went from E to C to B, so I've got to go from D to B to C. Triangle DBC. ECB, DBC, why? Because of AAS. think that's it. There might be another one. You can check and let me know.